Start.
Hello everyone, we are group 10 and we are going to tell about the update 2 on music recommender chatbot based on emotions. This project brings three exciting areas of technology: natural language processing, emotion recognition, and music recommendation. The vision is to create a chatbot that feels less like a machine and more like a friend, someone who not only listens but respond with the right music to match our emotions. So the next slide, the friend. The next slide is this slide is about core objectives. First, we aim to accurately identify the user's emotional state using natural language processing techniques. We trained a model using the Go Emotion dataset. Uh, this enables the system to move beyond simple sentiment into deeper emotional understanding. Then we move to mood mapping. Since 27 emotions are too complex to directly map to music moods, we created a simplified mapping system. These 27 emotions are grouped into six core moods categories for happy, calm, sad, energetic, and reflective. This makes it easier to connect the emotional tune to the music that fits. Next, we use music selection using Spotify audio features like Valiance, how positive a song feels, energy, and tempo. We filter songs that best match the user's mood. So, this slide is about the system architecture overview. We have designed the architecture as a multi-stage pipeline where each stage handles a specific task that brings the chatbot to life. The first one is about input text cleaning. This process starts when a user sends a message like "I'm feeling down today." This text is passed through a pre-processing layer where we remove unnecessary punctuations and symbols, converts everything into lowercase, eliminates stop words like the, is, and tokenize the text for model input. This helps the model focus on the meaningful parts of the message. The next is about emotion classification and NLP layer. The cleaned input is then sent to our NLP based emotion classifier trained using the Go emotions dataset. This model predicts one or more of the 27 fine grained emotions. The next is emotion to mood mapping. To make this emotion useful for music selection, we map the detected emotion into one of six broader mood categories. For example, sadness to sad, excitement to energetic, gratitude, calm, and so on. This mood abstraction simplifies music alignment, ensuring consistency and when selecting songs. The chatbot response generation. Finally, the chatbot crafts a response that empathetics and human like using person chat inspired templates. Instead of saying simply listen the song, it says sounds like you had a tough day. These songs might help you. The next slides will be continued by my teammate Vamsi.
Hello, hi, this is Vamsi. So this this slide says about emotion datasets, which we have 27 labels, which is mentioned by my friend Yoga. And then we actually did the overlapping, and there is a lot of imbalance in the data, which is needs to classify. And these are the challenges we faced during this data. So we need to simplify for model, and then we the main problem was the neutral variable. The neutral was feature was very dominant across all the moods, and then grief was very underrepresented. So where grief was under 1,000, neutral was had over 80,000 instances. So this caused the imbalance challenge for us, and then there was high variance caused the this cost is to poor accuracy for minor classes. So this skewed model. So this gravitated dominated models, and we ignored the important emotional cues. So we further mentioned we actually did the 27 modes into the six common modes, which were happy, sad, angry, neutral, fearful, and surprised, which we are talking on this at this part of time. So hap- we only choose happy, sad, angry, neutral because these are the common emotions we use on the daily process. Like when you say how are you, they say just I'm happy or else I'm sad. They just don't go over admiration and amusement. So we use the which are very common emotions, and then we simplified the modeling. This simplifies the modeling, and we also can improve accuracy during the prediction. And then this makes the music mapping more intuitive. So this actually helps us to provide more accuracy while choosing the music. And then different many songs for this also creates a space for more songs for every emotion. And then we this slide about label encoding and balancing. So we use the label encoder for numeric mapping, which we should do for the target variable, and then we downsampled happy and neutral because we had over 80,000. So we just put the lowest was fearful, which was about 15,000. So so we only had to take about three times the data of the lowest variable. So this is how we had a downsampling, and then we are using class weights to help and train the imbalance data, which is it tells the algorithm is like it equals 10 mistakes from in the highest variable to one mistake to the lowest variable, which is like it trains in a balanced way. So the solution benefits, we have a simpler, more interpretable target variable. So we have less label noise, better generalization now, and then we have strong model performance across underrepresented moods. So we also have seamless alignment with music features like valence and energy. So we actually make the outcomes of valence and energy both combined to give a appropriate mood, appropriate music for the mood we have. So from the next slide, my friend Sanjay will continue.
Hello, everyone. As my friend said earlier, there are 27 emotions, and we have classified into six emotions. So then we need to apply tokenization using NLTK library. This processing breaks down the user's sentence into individual tokens or words, making it easier for the model to process the emotion content. After tokenizing the words, we perform stop word removal to eliminate the common words such as is, the, and formats that do not do add meaningful content to the emotion. However, we made an important exception for the word not. While it usually classified as a stop word in emotion analysis, negation can drastically change the sentiment. For instance, not happy, the entire different from happy. Let's go for the next slide. Lemonization with WordNet. After removing unnecessary words, we focus on lemnisation, which is the process of reducing words to their base or dictionary form. We use the WordNet lemonization from NLTK to convert the variant of words like running into ran or runs, which are relevant and which will be found easier for the trend dataset. And this step helps in reducing redundancy in the test and ensure that similar meaning are grouped under one token. We primarily targeted verbs for lemonization as they can significantly emotional weight in sentence. For example, if a user say, I was crying yesterday, the word crying becomes cry, which can be more efficiently recognized by our emotion classifier and mapped correctly to the mood like sad. There are a lot of examples relevant to it. In next slide, I have used slang normalization, recognizing that a lot of chatbot use, especially younger generations, use modern slang or informal phrases like Gen Z words. We implemented a custom slang normalization step. This helps translate informal expression into standard English so that our emotion classifier can interpret the correctly. For example, words like lit are converted it to exciting, mood of mood of becomes relatable. They are so on. This mapping allows us to preserve the emotion meaning behind this term without the model getting confused by the slang. This step significantly boosts the system ability to handle real-world unfiltered conversation input in a natural, inclusive way. In next slide, we are pre-processing the example output. To show the pre-processing steps come together, let's look at the example. Suppose the user type I'm not even mad. That song was lit F. After tokenizing, stopword removal, and liminalization and slang normalization, this sentence is clean to not mad song exciting. The processed version is much simple and more suitable for our modern to understand while still retaining the emotional sentence of the original sentence by removing the noise and focusing on the sentiments. Our system is better equipped to classify the user mood and make an accurate uh, emotional music recommendation system. From here, then my friend Murli gonna continue the speech.
Hello, I'm Murali. Actually, for update one, we have shown you about the Spotify dataset and how did we worked on it. And this time we have gone through on Go Emotions data. So my teammates, all three of them, has given you a brief description of how they did, how we did like this. So I'm just gonna tell you what we did in the codes or something like that. So just to explain you what's the back process we did like that. So the first stage we took was like we uh, we tokenized the whole context and we standardized the words and we used it like stop word removal and lemmatization, which then stored in a clean text, which is used for like which was used to create the model. Uh, this made sure that the model is like sorry, languagically clean. So yeah. Uh, so this is what Vamsi has said that we have decided that to take just six uh, emotions, right? So what we did was like we found that there is a high imbalance in the data. So we then tried to do so many different things like removing particular variable or something like reducing particular emotional data or something like that. So end of the day, what we decided is, we can't interpret like fear, we can't interpret like achievement or for joy there are so many kinds of joys like joy, excitement. So we decided to combine all that emotions into six of them. So these trials are done to just to uh, check which variables are better. So yeah, that's why we have included this slide. Yeah, next slide. Yeah, these are the like future steps we are like the current steps we did and also the future steps which we are going to do. So we built a vocab from the clean text, like as I said before, we converted whole data into a clean text so that we could work our models through it. So that's what it is saying, and we embedded RNN and CNN models for classification. So yeah, next slide. So this is where it gets good. So like till now, we have worked on the both datasets. One is on Spotify. We selected which features are better for us to connect them to the emotion data. So on this time, we have worked on the emotion data, and we found, for which statement which emotion is going to get. Like we not completely work through it, like we are almost there, but now we have an idea what to do. So we are thinking about arranging the features which we got from the first data set to give if joy, then we need to give like valence high, energy high, and there is some other variables also like danceability and etc. So we are trying to find a good combination for each emotion so that we can give correct emotion and correct song. So this is a process like where we uh like divide the sentence into emotion and emotion to a song. So that is our whole process. So yeah, this is our so yeah, thank you. And the last thing I would like to say is like our next steps will be like implementing the chatbot and combining all this data. So yeah, thank you.